Okay, greetings of the day. I'm Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process, and today's topic is Introduction to Chemical Process. Okay, right. At the end of this session, student will be able to understand the basic working of plasma beam machining, understand the applications of plasma beam machining, understand the advantages and disadvantages of plasma beam machining. Okay, right. So here under chemical process, now we are jumping to this chemical and electrochemical. Okay, already these two parts that we have discussed so far. Now we are entering into the chemical process. Okay, right. The first one is chemical milling. CHM. In short, CHM is nothing but chemical milling. Okay, so chemical milling is the controlled chemical dissolution. Okay, CD. Chemical dissolution. In short, it is CD. Okay, so here chemical milling is the controlled chemical dissolution of the workpiece material by contacting with a strong reagent. Okay, right. Special coatings called maskants protect areas from which the metal is not to be removed. Okay, here special coatings called maskants protect areas from which the metal is not to be removed. So usually we need not remove the entire surface. Okay, so with chemical milling we can apply chemical, but in some areas only it should deteriorate or remove the material. In some other areas it should not remove any materials. So where we have to apply some coatings, those are nothing but muskets. Okay, right. The process is used to produce pockets and contours and to remove materials from parts having a high strength to weight ratio. Okay, so usually we need to remove the material in terms of some pockets. Okay, so the entire surface need not cut. Similarly, we can cut in terms of contours. Okay, so with different profiles we can cut, so the rest of the area can be shielded with some muskets. Okay, right. Chemical milling consists of the following steps. The first step, preparing and pre-cleaning the workpiece surface. Okay, first one, preparing and pre-cleaning the workpiece surface. This provides good adhesion of the masking material and assures the absence of contaminations that might interfere with the machining process. Okay, so usually we have to stick the glue, sorry, mascant. Okay, that is nothing but addition of the masking material to the workpiece, so where the material need not be removed. Okay, so for that, preparing and pre-cleaning the workpiece surface is very much required. Second step, masking using readily strippable mask, which is chemically impregnable and adherent enough to stand chemical abrasion during etching. Okay, so here the masking material must be strong enough to resist the chemicals. Okay, and it should capable enough to adhere with the workpiece material. Next, third step, scribing of the mask, which is guided by templates to expose the areas that receive chemical milling. The type of mask selected depends on the size of the workpiece, the number of parts to be made, and the desired resolution of details. Okay, silk screen masks are preferred for shallow cuts requiring close dimensional tolerances. Okay, next, the last step, fourth one. The workpiece is then etched and rinsed, and the mask is removed before the part is finished. Okay, right. Now let us look at this chemical milling setup. Right. During chemical milling in figure 2, the depth of the etch is controlled by the time of immersion. Okay. Now let us look at this figure. This is chemical reagent. Okay, and here heating and cooling set up with coil, and this is hanger, this is mask, this is stirrer to stir the solution. Okay, right. So this is the chemical milling setup. Okay, see here, this one is mask. Okay, so here you can observe undercut here. Okay, so this is the workpiece. Here mask is provided and hanger hangs this one. Okay, here undercut. Okay, right. In order to avoid uneven machining, the chemicals that impinge on the surface being machined should be fresh. Okay, so here the chemicals should be fresh, otherwise what will happen, it will corrode the surface. Right, the chemicals used are very corrosive and therefore must be handled with adequate safety precautions. Already we have discussed that if it is not fresh, the reaction will be different and it corrodes material unwantedly. Okay, the chemicals used are very corrosive and therefore must be handled with adequate safety precautions. This is very much important. Both the vapors and the effluents must be suitably controlled for environmental protection. See, this is completely with the chemical environment, so we have to take sufficient care towards the environment. Okay, agitation of the workpiece and fluid is usual. However, excessive solution flow may result in channeling, grooves, or ridges. So these are the problems reflected with the excessive solution. Right. Inclination of the workpiece may prevent channeling from gas bubbles. Okay. So here inclination of the workpiece is very much required. Okay, to prevent channeling from gas bubbles. Right. Here the researchers Bellows during 77, and as per the Metals Handbook 1989 reported that dishing of the machine surface occurs due to the uneven heat distribution resulting from the chemical action. So here three things, one after another based on the influences. Dishing of the machine surface occur due to the uneven heat distribution resulting from the chemical action. Okay. Typical reagent temperatures range from 37 to 85 degrees centigrade. Okay. So faster etching rates occur at high temperatures but must be controlled within plus or minus 5 degrees centigrade of the desired temperature in order to attain uniform machining. Okay, so here plus or minus 5 degrees centigrade is allowed. Okay, so faster etching rates occur at high temperatures. Okay, right. So with this, let me conclude. These are the references, and thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.